Yeah, so hello everyone. My name is Steve Houben. I'm a postdoc at University College London, and I'm very happy to today present our paper, which is titled WatchConnect, a toolkit for prototyping smartwatch-centric cross-device applications. And this is work done together with Nicolai Marquardt, who's also at UCL. So in recent years, we've really seen a widespread proliferation of all sorts of computing devices, ranging from very small devices like phones to mid-range devices like tablets and touch-enabled laptops, all the way up to very large interactive screens. And it really seems that people are increasingly interacting with different devices to interact with their information, which means that setups in which people are interacting with multiple devices at the same time are increasingly becoming more common. And the choice of the type of devices that they use is really governed by the affordances, capabilities, properties of the devices based on the context of use. So recently, smartwatches have become part of this ecology of people, providing yet another form factor to interact with their data. And smartwatches essentially provide a number of new interesting applications that allow users to, for example, interact with notifications or look at information at a glance, but also, depending on the built-in sensors, can really support quite complex health applications. So over the years, quite a number of research has explored interactions with watches and small screens. And these include, for example, explorations with on-the-screen interaction like facet, duet, or touch sense. We've also seen work on interactions with the bevel or the size of the watch, like the bezel interaction or the mechanical interaction that we saw at SIGCHI last year. A number of people have also explored how we can sort of move the input away from the actual watch to the band, like the watch it or the touch wristband. Another part of this design space is the above-the-device interaction, like has been shown by Harrison et al. In Abracadabra. And finally, the entire watch hand or arm can really be used to support gestures and postures, which has been pioneered by the gesture wrist system by Rikimoto, and a number of people have followed up on that. So although interaction with watches are pretty well understood, the shift from interaction with one device to interactions with a device ecology introduces a new set of design, engineering, and conceptual problems. And we're now seeing early explorations into connecting the watch to other devices or objects in our surrounding, like, for example, with smart objects, as done by Meyer et al. Also at SIGCHI last year, we saw how Duet actually introduced a system that would support both the watch, using the watch and phone in tandem to allow for these kind of transitions between background and foreground interaction. However, building these types of cross-device applications require a number of design and engineering skills to be in place. First of all, we want to design multi-device interfaces that provide a consistency across different devices in use. So we're no longer designing for one device, but we're really designing for the connection between different devices. We're also interested in gesture and posture recognition that we can do with the watch, and we can really use this to provide high granularity interaction, to provide seamless interaction techniques across several devices. Device connectivity and data transfer is also important because it essentially allows us to annex different devices together and to then distribute information within this device ecology. Then data processing and piping of different sensor and hardware data is also important because we need to be able to move motion and touch input between the different devices that we're trying to connect to each other. And finally, sensor and hardware configuration is needed to understand and design for existing hardware, but even more to explore novel hardware designs and think about different sensor modalities and what that might mean to the user. So in general, building smartwatch-centric cross-device interaction techniques and applications remains a very challenging and tedious task that is greatly limited by the existing hardware out there, but also by the path of least resistance design for most modern APIs. And this really limits the creative exploration of different form factors, different designs, and different applications that can really help us map out the design space to better understand the role of smartwatches in this larger device ecology. So to mitigate this problem, we introduced WatchConnect, which is a toolkit that consists of both hardware and software and allows for the rapid prototyping of watch-centric cross-device applications and interaction techniques. So the toolkit essentially abstracts a number of low-level problems such as gesture recognition, distribution of user interfaces, and hardware prototyping into sketchable hardware, high-level events and objects, and even a drag-and-drop user interface builder. And all of these things were basically put together to come up with a toolkit that really reduces the threshold to develop these kinds of applications. So the toolkit is composed of a watch probe, which is a wired smartwatch hardware emulator that has reconfigurable hardware on it. And this watch probe is connected to a flexible input-output platform that links the watch through a wire to a computing device. And on this computer, we then run a software stack that supports user interfaces and a wide range of input and output events to support the prototyping of these kind of cross-device interactions with a secondary device that has a touchscreen. As we can see here in the architectural drawing, the watch probe is basically a composite display with a number of add-on sensors that is then through a wire connected to a mediating platform that has a number of microprocessors, power and whatnot. And this sort of mediating platform is then connected to the computer that we actually want to prototype on. And the purpose of this toolkit is to provide designers with a fast event-driven platform for rapid prototyping these kind of watch-centric applications, like the one we can see here in the figure. And the toolkit does abstracts both the input and output space of the watch and combines it with the input and output watch in the input and output space of the second display to basically create sort of a volumetric space in which we can do a number of temporal cross-device interactions. So drawing from related work, the toolkit supports both hardware and software for on-the-watch interactions on the screen, on the bevel, and on the strap. We also support above-the-watch interactions using distance sensors so we can actually calculate where the hands are. And we can also do tracking of the entire watch hand orientation and movement using motion sensors. So using this technology, the toolkit can then recognize the watch hand touch input, which means that we can then sort of transform the 2D input on the screen to one that is specific for one smartwatch user. And this basically allows us to create customized user interfaces for people that also include sort of limited short temporal sequences of interaction above the display. So this is an example of one type of hardware configuration that one could use with this toolkit. And this watch probe with a wired connection consists of a display, a touch-enabled watch armband, distance and light sensors, and a capacitive touch sensor built underneath the display. So the sensors are then connected to an Arduino microcontroller that actually sends all the data to the computer. And the display is driven and controlled directly by the computer over a component connection, who can then send user interfaces directly to the watch. And this entire setup is then mounted in a 3D printed enclosure, so we can actually wear it as a real watch, and it is quite comfortable. So the hardware configurations can be sort of medium fidelity, where we basically solder something together, like the example probe that we can see in the figure here. But the toolkit is really also designed for these kind of lower fidelity prototypes, where we can use, for example, fidgets or Arduino to really quickly iterate through different hardware setups, where we can move the sensors very easily and sort of try out different combinations of hardware and software. So next to the hardware, the toolkit also consists out of a layered software stack that handles and abstracts all complex input, output, and processing into high-level events and objects that operate in a custom runtime that we integrated with Visual Studio. And these components include stuff like input that provides software support for touch, gestures, and tracking, hardware where we do a number of abstractions so that there's no difference whether you use Arduino fidgets or any other platform that you would want to add. There's also a network component that allows us to connect our watch setup to another WatchConnect deployment. We also provide a number of basic building blocks, UI component, and an actual complete runtime that allows us to also run the watch system in a simulator on the screen. Finally, we also provide a number of processing functionalities such as gesture recognition algorithms and filters that are used internally or that can be used by developers or designers directly. So WatchConnect also includes a number of custom tools that sort of support the exploration and visualizations of the different gestures and input events. And these tools really facilitate designers in understanding the input and output events, but also to sort of record and define thresholds, postures, and gestures that they don't want to use in their actual user interface. So to demonstrate the functionality and test the feasibility and applicability of the toolkit for the design of cross-device applications, we present 5 different interaction techniques that are implemented in a number of applications. So the first application is the classic problem multi-device interaction, where we want to send data from one device to another. And this screen basically recognizes the watch hand input and then shows a progress bar to visualize the connection process. And once connected, the user can move information between the watch and the second device by simply touching the screen and then gesturing in the direction of the screen. So touching existing resources on the screen will actually reveal on the watch whether that information can be sent back, and then the gesture direction the other way will actually send information back into the watch. A second example application is using the watch as a secondary display when interacting with map data. So the bevel of the watch here can be used to switch between map or satellite view, and then the mini-map on the watch is actually used as a scope that is kept synchronized with the main map. And these mid-air gestures are then used to synchronize the different zoom levels between both devices. Finally, the side bevel of the watch can also be used to add placeholders or add content to the map. A third example is a watch-aware user interface that reacts differently depending on how the watch hand touches the screen. So in this very simple example of a password field, we can actually use a non-watch hand to simply validate our password. However, if we touch the same button with our watch hand, we can then reveal the password either on the screen of the watch or on the main screen, depending on how we touch the screen. And then the password field can easily be reset by just tapping the validation button with the knuckle. So another type of application that we can support is the distribution of user interface widgets across devices. In this proof of concept, we show how we can basically send or beam a user interface from our watch to a nearby device to really start using that device input and output modalities. For example, in this case of Skype, where we have a small screen, we can walk up to a larger screen and sort of continue our Skype session there. We can also think of how we can actually use the watch as a configuration tool to allow us to configure our own touch input. So in this active reading application, the user can browse text with the dominant hand and then make annotations with the watch hand. And the watch hand thus can be reconfigured into different types of pens, markers, or other instruments that the users need. In this example, the user can switch between a pen or a brush, a marker, or reconfigure their hands into an eraser. And again, we can sort of play around with the hand, and similar to the duet system that we saw last year, we can just use the knuckle to, for example, select text. So the central purpose of this project and these example applications is really to explore the design space of this next generation of watch-centric interactions that sort of consider interactions with other devices. And this really poses new questions around how can we design for entire device ecologies rather than for individual devices. So we're interested in exploring new kinds of interaction models and concepts that we can then design into better systems. We're also interested in how we can provide feedback and feed forward to really support moving information between different devices. And we're also interested in exploring new types of hardware and sensors and see what their purpose is actually for cross-device interactions. So WatchConnect is a rapid prototyping toolkit that provides low to medium fidelity hardware to design high fidelity applications and interaction techniques. It essentially provides abstractions, building blocks, and tools that allow for the creative exploration of this kind of watch-centric design space. And the use of this kind of technology, this kind of probe over a real watch can be considered a limitation, but it's also a strength because it allows for really easy reconfiguration of the hardware, and it can really govern new watch designs and insights into what the function and the usability of hardware is for a specific use scenario. Finally, WatchConnect also provides a number of UI components and building blocks that actually make us or allows designers to create techniques and applications that have been presented before with little to no effort. So for future work, we're really interested in seeing how we can move some of these designs from this toolkit to real smartwatches and go like one step of fidelity higher. We're also interested in sort of seeing how we can support collaborative setups, for example, around interactive tables or large public displays. Also, since we've been talking about device ecologies, we're also interested in seeing how this would scale up to maybe interaction with 3 or 4 devices at the same time. And finally, in our paper, we evaluate our toolkit using Olson's framework, but we're also really interested in sort of bringing this out and giving this to designers to see what kind of ideas they can come up with. Thank you very much.
Thank you. This is Sharon Oviatt. It's really wonderful to see a talk on prototyping tools for the wearable space. One question I had was, obviously with a lot of the wearables, the smartwatches, keyboard is gradually going away. Many gestures we've seen on smartphones are also disappearing. But the use of speech and spoken dialogue, which is having a renaissance in the last couple of years, will become much more central. And I wondered if you currently have, or if there would be any way to extend your tools to support spoken input, and also to look at joint input from two or more, say a touch plus speech, which would require collecting fine-grained timing information. And I just, anyway.
Yeah, so the toolkit currently doesn't provide support for voice, but it would be extendable as one extra input modality that we can provide. So it would be just a matter of sort of building a wrapper that would allow us to connect that type of input to the watch. About the combination, I think that's a really interesting point, and that's also something that in the toolkit we try to do, allow users to, or designers to build these kind of temporal sequences of interactions. And I think that, yeah, that sort of exploring that in more depth, and also scaling it up to more devices, I think is a really interesting future work, yeah.
Antonio Krüger, DFKI Saarbrücken. Thanks a lot. I also believe that toolkits of these kinds are very, very valuable, and there's just a little work on these kind of contributions. I was a little bit wondering about the role of the dominant hand or the non-dominant hand in the different pointing tasks you have. You know? So there seems to be a slight dilemma in a way where the watch is placed. So either you have to point to the watch with your non-dominant hand, or you have to point with your non-dominant hand to the second screen. I was wondering how you want to solve this. Two watches actually on both ankles or both wrists.
Well, I think it's very unlikely that people will wear even more than one watch, but I think that's an interesting question, and I don't have an answer to that, but I think that the toolkit would allow you to actually find that answer out, so you should download and use it.
Right, I've got a question, which is, have you considered how you can extend this to being actually mobile, on the go, interacting with a phone, for example?
Yeah, so at the moment we're actually exploring two ways here. Like one where we can actually make the probe completely wireless and see if it would still sort of allow for the same reconfigurability. And secondly, we're also extending the toolkit to actually work with off-the-shelf smart watches to sort of support some of these prototyping or prototyped interactions and applications. But there, of course, you have a little bit of the problem with the hardware that's not really transferable easily to other watches. But it's something we're definitely looking at the moment, yeah. Okay, thank you very much.
Right,